Alright, let's take a look at how handy a Minitab can be for calculating Poisson probabilities using that probability distribution plot that we looked at for the binomial probability distribution. Let's look at the newspaper problem that's so typical in a textbook when there are a mean number of typographical errors on a page. So let's say the problem is a newspaper finds that the mean number of typographical errors on a page is 4, or it's per page. So there's our interval. Our interval is per page, and we're looking at the mean number. So there are our key words. We see mean number, it's an average, and we have an interval of per page. So right away we have those key words that tell us we're looking at a Poisson distribution. So we want to find the probability that exactly 3 errors are found on a page, at most 3 errors are found on a page, or more than 3 errors are found on a page. So we can use Minitab to calculate those for us. We don't need to fool with all those formulas, which is nice. Minitab does all the heavy lifting for us, and then we can just interpret what Minitab gives us. So what we're going to do, we have our steps listed out here for us. We're going to use the graph function and then our probability distribution plot, just like we did with the binomial probability. But when we get under there, we're going to tell it to look at the Poisson probability instead of the binomial probability. So let's open up Minitab and take a look at what we're going to do. When you get in Minitab, as I said, go under Graph. Go under the Probability Distribution Plot and click on View Probability. Click OK. Go under the drop-down box and tell Minitab that you want to look at the Poisson probability distribution. And then tell it what your mean is per interval. And in our problem, it said that the average number of errors per page was 4. So we tell it that we have approximately 4 errors per page. And then we want to look at the shaded area tab, because we want to look at the shaded area on our distribution plot. We want to click X value because we're interested in finding how many what's the probability of 3 errors, at most 3, less than 3, equal to 3. We're interested in that number. So how do we set this up? Our X value that we're interested in is 3. So we want to put 3 in and tell Minitab that we're interested in 3. Now, we have all these different charts here that are going to tell us different things. If we use the middle chart, it's going to tell us in between 2 values. If we use the both tails chart, it's going to tell us out in the tails of greater than or less than specific values. If we use just the left tail, it's going to tell us less than to the left out here. If we use the right tail, it's going to tell us greater than a specific value. So if we use the X value of 3, let's see what we need to know. So we're interested in exactly 3 in our first problem. So in symbolic form, finding the probability of exactly 3, that means we're just looking for X equal to 3. We're just interested in what's the probability of X equal to 3. So we could actually use any of these plots for X equal to 3. So let's just see what we get when we do X equal to 3. We could actually choose any of these. When we want X equal to 3, we just want this bar right here. So if we just let it plot anything at all, when it comes up, this value right here, the 0.7619, is actually telling us the probability of 3 and greater than that. We don't want that number right there. We want that bar. So if we just hover our arrow right there on that 3 bar, it tells us that the Poisson probability of X equal to 3 is 0.195367. So that's our probability of that single bar of X equal to 3. So that probability is equal to, I'm going to type that in here for you, 0.195. I'm going to put that in there. All right, so at most 3. So let's figure out what that one should be. The probability of at most 3 in symbolic form would be at most 3. Well, how do we write at most 3? That means that we can go up to 3, we can include 3, but we can't do any more than 3. So we're looking at X less than or equal to 3. So x less than or equal to 3. So we want less than or equal to 3. So what we want when we want less than or equal to 3 is this column right here. We want the left tail. So we want to enter the exact number of interest. So let's go back to Minitab. And we're going to go back into our dialog box. Now remember, I showed you can just go back up to this button and open it back up. Go back to your shaded area, and we want less than or equal to 3, so go to your left tail, and we want to include the 3 bar, and we want to go 3 and behind it, or in front of it, depends on how you look at it. So 3 and everything below it. So that probability is what's given right here. So if you were to add up this bar, if you hover over there and you get that value, and you hover there and you get that value, and that value, and that value, excuse me, and add them all up, it would equal 0.4335, which is pretty convenient, right? That Minitab does all that for you. So let's do the last one. So what's the probability that more than 3 errors are found on the page? Well, more than 3 means greater than 3, but not including 3. So we have x greater than 3. So that means in our calculations, we do not want Minitab to include that bar of 3 in the plot. We don't want that one bar of 3, that probability of 3 of 0.195 to be added up when it adds up the probability values. So that means when we go back in here, we want Minitab to add up everything to the right except for that 3 bar. So that means we need to change this x value and tell it to start adding up at 4 and go to the right. So we want to go right tail from 4 on. So from 4 on all the way out is 0.5665. Now, I've also written that one up here. I should have talked about that one here. For the right tail, enter the number of interest plus 1. And the reason for that is because we don't want to include that number that we're sitting at. We want to start out bigger than that and go all the way out to the right. So that's how we would use Minitab to calculate the Poisson distribution.